Hello class, this is lecture 12 and I'm your professor John Rabeck, and this is Econ 4001.02. So this lecture is going to cover marginal utility, and we're also going to cover how marginal utility can relate to the marginal rate of substitution. So how do we do this? Even though utility is ordinal, we can define a notion of marginal utility, which is how much utility you get by increasing the amount of some good. What is this in terms of like math? Yeah, so this is the amount of utility you get by consuming a marginal unit of some good. So you can do this for any good. Here we're just going to do it for good 1, but you can do it also for good 2, right? So mathematically, the marginal utility of good 1 is just the derivative of the utility function with respect to x1, right? So this is how much more utility you get when x1 increases a little bit. And we'll use this later on to discuss how properties of optimizers works as well. You can also define the marginal utility of good 2. This is just going to be the derivative of utility with respect to good 2. Right, so we said that utility was ordinal. So how does marginal utility have any meaning whatsoever? And it doesn't really have any meaning. But if we take ratios, it turns out that we'll end up with the marginal rate of substitution, which is the change in the amount of a certain good with respect to another good in order to stay indifferent. So taking these ratios will actually give the calculus version of the marginal rate of substitution. So how do we get this? Well, we just look at the total derivative of the utility function, holding it fixed at some level u bar. So if we do this, we get 0 is equal to the derivative of the utility with respect to x1 times the change in x1 plus the derivative of u with respect to x2 with the change of x2. And if we rearrange this, right, we can get the marginal rate of substitution, because recall that this is holding the utility level fixed, right? So right here, utility is fixed. So that's true when deriving this equation. So we see that the change in x2 with respect to x1 is actually just going to be negative the ratio of the marginal utilities, where now the marginal utility of 1 is in the numerator and the marginal utility of good 2 is in the denominator. And this makes sense if you just think of these units, right? So it's, units good 2 over good 1. And here this is utils over good 1 and utils over good 2. So if you just look at how the units cancel, it's the same thing. Great. So that's how the marginal utility is related to the marginal rate of substitution. We can just go through a quick example here, right? So suppose the utility function is given by this, and in this case, marginal utility of 1 is just equal to 2, and the marginal utility of 2 is equal to 5, right? So these are just the partial derivatives of the utility function here with respect to x1 and x2 respectively. So if we look at MRS of this x, this is going to be the change in x2 with respect to x1 such that utility u bar is equal to, we can just plug these in, so it'll be 4 plus 5 here. So u bar equals 9, and this is just, it's not going to depend on either the evaluation of x or the x or of good 1 or good 2 in this. So it's going to be -2 over 5. So this means you give up 2 units of good 2 for every 1 unit, or sorry, you give up 2/5 unit of good 2 for every additional unit of x1 you get while you're on this utility curve where it's equal to 9. Great, so what did we do here? Well, we defined marginal utility and we showed the relation to the marginal rate of substitution. So again, this marginal utility thing will come up again when we're solving different optimization problems. Great, thanks for listening, and I'll see you again later.